Hello everyone, my name is Rohak, and in today's video, we're going to be employing Plotly data visualization techniques to accurately assess the scope and frequency of forest fires across Brazil. But this isn't merely a tutorial in computer science. It tackles an impactful issue that can have potentially devastating long-term implications. From 2001 to 2021, Brazil has played bystander to a 27.8 millihectare loss of tree cover from fires. More than 3,980 square kilometers of the Amazon, an area 5 times the size of New York City, were cleared in the first 6 months of 2022. This exploration in data science will therefore seek to leverage computing for a greater purpose. After all, that's what technology is all about. Well, enough of me talking. Let's dive right in. Now that we're in our Jupyter notebook, we can officially begin performing some fascinating data visualization with the Plotly Python library, where we'll be examining forest fires in Brazil with in-depth visualizations and high-level analytics tools. So before we do anything else, we need to import the following libraries: NumPy for handling arrays, Pandas for data frame manipulation, and all of the relevant Plotly modules and classes that we'll need. With that out of the way, we can read in our forest fires dataset with the read CSV method of Pandas and visualize the first 5 rows using the head method. And if we do so, we yield the following dataset, where we have the year, state, month, and number of wildfires recorded for a specific time interval. The next thing we really want to do is check for any null or missing values that may be present within our data frame, since this may lead to some unintended consequences when we perform some of our downstream analyses and pre-processing steps. So to do this, I've called the isNA method, which essentially cycles through the data frame and checks for any null values, and I've summed this for each column so that we get totals corresponding to each feature. So if we run, we yield a total of 0 for all of the different columns, which means we're all set and good to go. Now that we've read in our dataset and checked for any outliers that we might need to take care of, we can now move on to the data preprocessing stage. As with any other machine learning or data visualization process, it's always important to conduct some sort of pre-processing beforehand, since this takes care of any annoying issues that we might want to get out of the way to begin with. So if we print out all of the states and months included in our dataset, you might notice that something is off. And you're exactly right. All of these words are written in Portuguese, which is a bit problematic since it kind of reduces the overall readability and accessibility of our dataset. To resolve this, we can simply apply a mapping function in which the old values of our original data frame are linked with their corresponding English versions. And if we use this on our month column, we get a newly formatted version which aligns with what we want to see. And if we visualize all of the unique values, we can see that they're all formatted properly, which makes things a whole lot easier. The next step of our data preprocessing has to do with our date column. As you guys can see, all of these values are represented as raw timestamps and are thus really hard to apply for some of the downstream data visualizations that we're going to want to try out. To fix this, we can simply call the dateTimeIndex function of Pandas and pass in our date column as a parameter. Here, it's also worth pointing out that we're accessing the year field of this newly formatted object, which means that we're specifically getting the year out of the timestamp. So if we print out all of the unique years that are represented, we yield the following array. And as you can see, this is a whole lot easier on the eyes. So after dropping the columns that we don't need and renaming the ones we have appropriately, we can get the following data frame. And this is much better than what we had earlier. Our month issue has been resolved and the years are represented as nice clean integers that we can work with easily. Having wrapped up with the data cleaning and preprocessing stages, we can finally move on to the data visualization. So, considering the wide array of factors that contribute to wildfire occurrence, which include temperature and soil moisture, cleanly visualizing trends in fire density across a large time span is critical in informing future inquiry into this area. As such, we'll be working on creating a time series to model wildfire trends on a year-by-year basis. To start off, we first want to generate a data frame with a single year and a corresponding number of wildfires assigned to that value. So what I've done here is I've assigned this list called years to all of the unique years represented in our dataset, and then utilized a for loop to extract all of the total fires for that specific year. So using the lock method, I've accessed the specific year, and then I've taken the fire number column for that specific entry, rounded it to 0 for increased readability, and appended it to a separate list that we've used to construct a new data frame. So ultimately, as you guys can see, utilizing the for loop that I talked about earlier, we have our specific year and the total fires associated with that year. And utilizing this raw dictionary, we can then convert it to its corresponding data frame representation. And if we visualize this, we get our year and the total number of fires recorded in that particular time interval. Awesome. After this, we can go ahead and create our time series. So first, we're going to want to create a figure, which you can kind of think of as the base instance that will be used to render our illustration. And then inside of our figure, we can create a scatter object and pass in multiple parameters that refer to our image. So for our X and Y parameters, I've specified the year and total fires columns of our newly created dataset, respectively. And then in our mode parameter, I've specified lines plus markers to indicate that our illustration will ultimately resemble a line plot, but also have markers in between to delineate specific time points. And finally, I've set the color of our line to blue for increased readability. The next plotly function that we're going to be using is update layout, and this, perhaps intuitively, does exactly what it implies. In a nutshell, this method is responsible for adding high-level modifications to an already constructed image. This could come in the form of a title, a few axes labels, or some minor changes in margin styling. Here we've added a title, some padding, and a few axes labels to make our illustration come to life. And if we visualize the result, we get this cleanly illustrated visualization. As you guys can see, what makes PyPlot so special is that you can actually hover over the image and access these individual points, and then we also see this trend line that goes through our data and that kind of models the different fire density patterns that are being observed on an annual basis. What's really cool about Plotly is that it functions as a kind of interactive web-based visualization in which you can have all of these options. So here, as you guys can see, I can choose to zoom in. I can also lasso select specific aspects of the plot that I want to dive deeper into, and I can also save or download this plot as a separate PNG file if I want to work with it in the future. Now that we have a general idea of how the wildfire totals tend to deviate on an annual basis, let's dive deeper into the individual states themselves and see how they compare against one another. First, we need to generate a dataset like we did earlier, except this time, instead of having total fires sorted by year, we need to have total fires sorted by state. So what I've done here is created two separate lists that each hold the state and year values respectively, and I've also instantiated a new data frame that'll hold our updated data. But what I really want to highlight is this nested for loop. So here I've iterated over each state, and for each value we pass over, I've created a state-specific data frame that is essentially a subset of the original dataset, but only containing the entries that correspond to the specific state being looked at. So if we take a look at the second portion of our nested for loop, where we iterate over each year in our years list, we can see that we're essentially performing the same procedure as we did earlier, where we sum up the total number of wildfires recorded for each specific years and round up the totals for increased readability. Ultimately, all these wildfire totals for each and every year are totaled up into a list called LI, and we assign a column of our new data frame consisting of the given state to that list to create our newly formatted data frame. So if we take a look at this newly formatted data frame where we have wildfire totals for each and every year for a specific state, we yield the following. As you guys can see on the far left, we have a year column with all of the specific years. Once again, this is only the first 5 rows, so we're only seeing the first 5 year values. But essentially, for each and every different state, which is designated on its own column, it has its corresponding number of total wildfires for that particular year. After resetting our index and renaming columns for further clarity, we get the following dataset. And as you can see, this contains the top 10 states and their respective amount of total wildfires. So now we can move on to creating our bar plot. And for this purpose, we can leverage the bar function of Plotly Express. And inside, you'll notice I passed in the data frame we generated earlier, represented the X and Y subsets to their corresponding variables, set the color of the hue variable, and assign labels to display as a legend on the graph. Additionally, with the update layout function that we used previously, I set a tick angle for the x-axis labels, specified some text for the title header, and also added some padding for increased visual appeal. If we take a look at the resultant bar plot, we get the following, where we have states on the x-axis and reported fires on the y-axis. Notice if I hover over each of these bars with my cursor, I get the specific state in question along with the amount of reported fires. Additionally, this bar to the right acts as a sort of heat map, where we have varying intensities of color depending on the amount of fires reported. This not only clues the reader into the areas affected the most, but also adds kind of a visual cue as to what areas are in need of the most help. Finally, utilizing the data generated earlier, we can create a geographically centered scatter plot that visually resembles the regions in Brazil most affected by wildfires. This can not only function as a high-level insight into which areas are the most prone to disaster, but also has the potential to target research into specific locations of interest. So looking at our first cell, you guys can see that I've specified latitude and longitude values representing each of the 10 states that we looked at previously. Eventually, both of these lists functioned as coordinates from which I could relay data through the geographical scatter plot. So if we run our code, we can see our final data frame. As with before, we have our state, the amount of reported fires associated with that location, and we also have our latitude and longitude coordinate values that we generated just now. Finally, to make this visualization come to life, we can leverage the scatter geo function of Plotly Express. So here we've passed in several values for the various hyperparameters. For our data frame, we've simply specified our data. For our scope, we've actually set this to South America, which is obviously the continent that Brazil is located upon. And what's really cool is that when this plot is visualized, it'll actually be the outline of the South American continent. And within that outline, each and every one of these points that we've designated will appear. And utilizing some of the other hyperparameters, I specified the latitude, the longitude. Once again, these were the names of the columns within our data frame. Additionally, to specify the size of the coordinates, I set that to the amount of reported fires in that specific region, so that areas with more fires would be depicted as much larger than those with a relatively smaller amount of fires. Finally, I set unique colors corresponding to each individual state and set the hammer projection for increased readability. Per usual, I also included a call to the update layout function where I specified some title text and added some padding. So if we visualize our final figure, we get the following. And as you guys can see, we have all of the different hotspots graphically visualized in our geographic setting. You can see that each state is represented as a different color, And if we hover over these hotspots, we can see the amount of fires and also the state which we're referring to. This is Plotly data visualization in action, making ideas come to life one line of code at a time. I hope you guys enjoyed this video, and if you learned a thing or two, feel free to like and subscribe to the channel for more. Ultimately, my mission is to demonstrate that technology is not an abstracted realm out of our reach, but instead a catalyst of change that can truly affect a large-scale impact. So, with that aside, take care, have a fantastic day, and as always, I'll see all of you in the next one.